Have a nice day, everyone. Welcome back to my lesson tutorial about grade 8 mathematics lessons. Our topic for weeks number 6 and 7 for the second quarter is about the conditional, inverse, converse, and contrapositive statements. As a recall, let's take a look at our previous lesson during week 5 about conditional statements. Conditional statement is an if-then statement in which the if clause is the hypothesis and the then clause is the conclusion. Example of conditional statements. Number 1. If you are good in math, then you are smart. Hypothesis. If you are good in math. Conclusion. Then you are smart. Another example. If a polygon is a quadrilateral, then it has 4 sides. Hypothesis. If a polygon is a quadrilateral. Conclusion. Then it has 4 sides. Now, after discussing all about conditional statements, we have another statement to take a look at. When we switch the hypothesis and conclusion of a conditional statement, we form a converse statement. Examples. Number 1. Conditional statement. If the triangle is equilateral, then it is equiangular. Its converse is, if the triangle is equiangular, then it is equilateral. So as you can see, the hypothesis and conclusion of the conditional statement is being switched or exchanged. Another example, conditional statement. If a man is honest, he does not steal. Its converse says that if a man does not steal, he is honest. Now, if we examine the conditional and the converse statements of the previous examples, they are as follows. The conditional statement is true. An equiangular triangle is always equilateral triangle. The converse is also true. An equilateral triangle is always equiangular. Since both conditional and converse statements are true, we may connect the phrases by if and only if, or in symbol IFF. Thus, it forms a biconditional statement. Example. Biconditional statement. A triangle is equilateral if and only if it is equiangular. The words if and only if implies that both conditional and inverse statements are true. Another. Biconditional statement. A man is honest if and only if he does not steal. Given a biconditional statement, we can split it into conditional statement and its converse. Example. Biconditional statement. Two angles are complementary if and only if the sum of their measures is 90 degrees. For the conditional statement out of this, if two angles are complementary, then the sum of their measures is 90 degrees. As you can see, the words if and then are being added. And then for the converse statement, if the sum of the measures of two angles is 90 degrees, then they are complementary. So in here, the hypothesis and the conclusion of the conditional statement are being switched. At the moment, 3 statements were being discussed: conditional statements, converse statements, and biconditional statements. Now, aside from these 3 statements, another 2 statements can also be formed out of this. Both the conditional and converse statements are true. Aside from forming a converse statement from conditional statement, we can also form the inverse statement. What is an inverse statement? An inverse statement can be formed by negating the hypothesis and the conclusion of the conditional statement. When we say negating or negate, we mean we make negative in meaning by using words like no, not, or don't. When we negate the converse statement, we form contrapositive statement. For more concise description and differentiation of the statements being presented, I have here symbols for easy understanding. Take note that the small letter P means hypothesis and the small letter Q means conclusion. For conditional, if P, then Q, or P implies Q. For inverse, in which the hypothesis and the conclusion are being negated, if not P, then not Q, or not P implies not Q. For converse, in which the hypothesis and the conclusion of the conditional statement is being switched, if Q, then P, or Q implies P. And then, for contrapositive, in which the converse is being negated, if not Q, then not P, or not Q implies not P. Example number 1. A polygon with exactly 4 sides is a quadrilateral. The conditional of this statement says that if a polygon has exactly 4 sides, then it is a quadrilateral. Its inverse. If a polygon does not have exactly 4 sides, then it is not a quadrilateral. For the converse, or the inverse of the conditional, we have, if a polygon is quadrilateral, then it has exactly 4 sides. Contrapositive, not Q, not P. If a polygon is not quadrilateral, then it does not have exactly 4 sides. Example number 2. 2 line segments of equal length are congruent. Conditional, P implies Q. If 2 line segments are equal in length, then they are congruent. Inverse, not P, not Q. If 2 line segments are not equal in length, then they are not congruent. Converse, if Q, then P. If 2 lines are congruent, then they have equal lengths. Contrapositive, not Q, not P. If 2 line segments are not congruent, then their lengths are not equal. Example number 3. 4x minus 6 equals 26. X equals 8. Conditional, P implies Q. If 4x minus 6 equals 26, then x equals 8. Inverse, not P, not Q. If 4x minus 6 is not equal to 26, then x is not equal to 8. Converse, Q implies P. If x equals 8, then 4x minus 6 equals 26. Contrapositive, not Q, not P. If x is not equal to 8, then 4x minus 6 is not equal to 26. So for practice exercises, kindly answer learning task number 2, 3, and 4 on page 25 of your math module. That's all for now, and thank you for listening.